Aloha kako. Hello, everyone. Welcome to Live from NOIRLab at Gemini. I'm your host, Alyssa Leilani Grace. Today's guest is Rob Sparks, and our moderator is Jamika Marshall. We're all employees of NSF's NOIRLab, and we're all very excited to talk to you about developing your own astrophotography hobby. In a previous episode of Live from NOIRLab, we interviewed Dr. Jason Chu about his own astrophotography practice, and we received so much interest in the topic, we thought we'd create this video to give you more of a step-by-step guide to taking your own images of our universe. Please remember that if you have any questions or comments, you can leave them in the YouTube chat, and Jamika will read them aloud. Now let's fully introduce our special guest, Rob Sparks.
Hello, how you doing, Alyssa?
Great, how are you, Rob?
Good, good. Are you gonna do the rest of the other announcements first and then come back to me?
Yes, I'm just going to introduce a little bit of your background real quick.
Okay, super, you can go ahead.
So Rob Sparks works on a variety of projects in the Communications, Education, and Engagement Department at NOIRLab. He has taught high school and community college physics, math, astronomy, and improv theater. He worked on the Sloan Digital Sky Survey as the Fermilab Teacher Fellow and the National Radio Astronomy Observatory in the Research Experience for Teachers program. Outside of work, he can be found running, on stage at local theaters, and playing with his cats. Thanks for joining us, Rob.
Okay, and I'll see you in a minute.
Okay. Now, before we let Rob talk about his awesome astrophotography, we're going to talk a little bit more about the Gemini North Telescope and Gemini Observatory. Okay. Whoops. The Gemini International Observatory is a program of NSF's NOIRLab. Gemini Observatory, like the constellation, is a twin telescope with one telescope located in Chile and the other located near the summit of Mauna Kea on Hawaii Island. Our international participants include the United States, Canada, Chile, Brazil, Argentina, and Korea. Now, Mauna Kea is one of the best places in the world to observe the stars, and this video shows us one of the reasons why. The summit area is extremely dry and stable due to a phenomena called an inversion layer. The tropical cloud layer, illustrated by this video, keeps the upper, drier atmosphere separate from the moist air beneath the clouds. The dry and stable environment allows for better atmospheric seeing. Seeing is a term astronomers commonly use to describe the quality of the sky for clear observations. Mauna Kea has some of the best seeing in the world. For our Gemini Science update, we're throwing it back to our press release, The Cosmic Tempest, from April 2020. Pictured here is an artist's rendition of the most energetic wind from any quasar ever measured. This outflow, which is traveling at nearly 13% the speed of light, carries enough energy to dramatically impact star formation across an entire galaxy. The left picture illustrates the central portion of the galaxy home to the windy quasar as viewed in optical wavelengths. And the right is the view in infrared. This windy quasar lay hidden in plain sight for 15 years before being unveiled by innovative computer modeling and new infrared data from the International Gemini Observatory. For more information on this discovery, visit our website, nationalastro.org. Now, without any further ado, let's learn astrophotography from Rob Sparks.
Okay, thank you, Alyssa. I'm going to click share my screen here, and hopefully it will. Oh, it did that again, didn't it? We went over this before, and I forgot to switch back to make sure it switched. There we go. Is that showing the screen now? It's not showing the screen yet. Come on now. Come back, Zoom.
Yes, as we've all learned from doing these live from NOIRLab presentations, Zoom can be a little tricky, especially with Macs. Just a heads up for
Yeah.
anyone else who's planning their own presentations.
Yeah, so now it's, there we go. So we sharing my screen now? It looks like we are, right?
Yep.
Okay, super, yeah. Zoom is a wonderful tool and also a frustrating tool, as I'm sure many of you are learning over the years here. Anyway, my name's Rob Sparks, we introduced earlier a little bit, and I call this Random Adventures in Astrophotography because I never really, got out, thought I was going to be an astrophotographer, or just sort of stumbled into it about, around 2007, 2008 when I got my first DSLR and started trying things and, just at night and seeing what happened. I'd had no class or no guidance from anyone else, and made a lot of stumbles along the way, of course, but also a lot of discoveries along the way. And hopefully I've gotten a lot better as time has gone on. And I'm going to sort of take you through some of my journey and some things you can try and give you some tips to help you maybe have a little bit less steep of a learning curve than I did at the time. Plus, things have advanced a lot since 2007, as you know. So we have new tools that can actually help us do astrophotography now that are not even available back in 2007. Also, in this COVID time, it is a great hobby for social distancing, because typically you're by yourself or with a small group of people or maybe a friend or loved one out at night under the stars. So typically it's a great way because you want to get away from people. So it is a perfect thing to do in the social distancing time. So anyway, just as we said earlier, I'm a education and engagement at NOIRLab, and that's a picture of me from one of the shows, many theater shows I've done in Tucson, which is a very NOIRLab type outfit I was wearing for that particular show too. Is that I consider myself a bit of a hacker in a good way of being an astrophotographer. I learned by doing. I learned by trying things and seeing what works and what doesn't. And that's typically what hackers do. They have a problem, they try different things and try to arrive at a solution. And it may not always be the most elegant solution at first, but hopefully as time goes on, their solutions get better and better. And that's sort of how I've been going over the years. So let's without further ado, let's jump right into it. So I have a wide variety of equipment that I've used over the years. And you don't need all this equipment. Remember, I've been doing this since 2007, so I've acquired a variety of different lenses. Currently, I have two different cameras, a Canon 80D and a Canon 6D. I will just mention those quickly because one is what we call a crop sensor and one is a full frame sensor. And that can be an important consideration when choosing a camera. A full frame sensor means 35 millimeter sensor. 35 millimeters, just like 35 millimeter cameras. Okay, a crop sensor is a smaller sensor than that. For usually about 24 millimeters or so for the Canon 80D in the 24 millimeter ballpark. Now that means, of course, you're going to have a slightly smaller field of view on your camera. So the same lens put on a full frame camera will give you a smaller field of view on a crop sensor. So if you want really wide fields of view, you want a full frame sensor. But the crop sensor has its advantage too, because if you're trying to zoom in on something, the smaller pixels will give you a little increased magnification. So for instance, if I want to take a photograph of something really close up, that 150 to 600 millimeter zoom lens I have, if I put my 35 millimeter camera, will give me a certain magnification. But if I put it on my crop sensor camera, it gives me what's called a 1.6 crop factor. So it acts like a 980 millimeter lens on my Canon 80D. So I can get a lot more zoom with the same lens. So again, there's advantages and disadvantages of each type of camera. So you have to choose what you're trying to do, and you can make your choice that way. So I like having both a full frame and a crop sensor in my bag just for that reason, so I can decide whether I want to go for more magnification or a wider field of view with the same lenses. It's almost doubling the lenses. Plus, there are nights I set up two cameras to do photography at one time, so it's also nice to have that extra camera that way. I also have a OnePlus 6 cell phone. Cell phones these days, I'm going to put it in front of my face here. Cell phones these days are getting much better. They're actually becoming a little bit useful for astrophotography. So I'll show you a couple pictures I've taken with my OnePlus 6 here. It's a 2018 vintage cell phone, so it's over 2 years old, and the newer cell phones have gotten even better than this. And as you'll see, this one's not bad. This one is pretty good for what it is. We also have a ZWO 1600 CMOS camera. That's a very advanced monochromatic camera used for astronomy. I have some wide-angle lenses, a 14 millimeter lens, a 10 millimeter diagonal fisheye lens. You'll notice that when I do diagonal fisheye, you'll see the image gets distorted at the edges because it's like a fisheye view. I also have a full circular 5.8mm fisheye lens. I'll show one picture taken with that, which does great for doing all sky views. For long exposures, I have a couple of sky trackers because you have to guide the camera to track the stars and do long exposures. I have an iOptron sky tracker I got years ago. And then a couple years ago for the solar eclipse, I got an iOptron Sky Guider Pro because I wanted something capable of holding a slightly heavier lens for the solar eclipse. And NOIRLab has an 8-inch telescope I sometimes use as well. And of course, for all this stuff, you need a tripod or adapter of some type. Like I said, if you don't have all this stuff, don't worry. You can just start simple with your cell phone. So I'll start with the cell phones, I believe. So what do you really need? A camera of some type, which can be as simple as your cell phone, a tripod, some sense of adventure, and a willingness to try new things, and hopefully a curiosity to learn. Because that's what really drives me, is the curiosity, thinking, hey, can I do this? Is this something I can actually do? Can I take a picture of this comet passing by Mars or something like that? Which I did several years ago with I know people got better pictures than I did, but no one got a picture using the smaller telescope than I did because I used my camera with a zoom lens. So I'm pretty sure no one got a picture of it with a smaller instrument than I did. And this actually picture right here is a cell phone picture from Tucson here, taken with this 1+6 camera right here. Just outside the desert here to my east a little bit. It's on a full moonlit night, so you get the nice foreground lit up with nice stars in the background. So it's one of those fun nights when you can see the saguaros and the cactus in the foreground with a nice moonlit night in the background. Just the right amount of moonlight, not too much, not too little, to get this lovely moonlit desert view. Oops, wrong button. As usual, I meant to advance and I actually exited the screen. So we'll try to advance here. So
I have a quick question for you.
Yes.
In the spirit of starting someone's own astrophotography practice, I wanted to ask if from that list of all your gear, if any of those things were one of the first things that you had when you started astrophotography, or have you sort of outgrown all of the first things that you had?
I'm sorry, you faded out there. Is it or first things I had or what?
Or have you outgrown all of those first?
Your audio is breaking up. I can't quite hear the question.
My question was if you still, any of the material that you showed us were the first camera or the first lens that you had when you started out doing astrophotography, or if these are all newer items that you've acquired after learning how to do stuff.
Most of them are newer items, but to be honest, that's because the equipment is advanced since then. If I were starting out now, I would probably buy some of the stuff I had right now as my first stuff. I'd probably buy that Canon 6D with my nice 24-105 lens as a nice kit lens to get started. But back then, of course, the equipment was different, so I bought a different camera and it came bundled with a different lens. So, but almost everything I have on there now has been purchased since then.
Okay, I think we have some questions from the YouTube chat as well.
Yes. Is there another question?
Yes, so we did have a question from our YouTube audience. You actually have kind of answered it already, but I'll go ahead and read it. This question is from Beverly T. She says, is it possible to maybe use your phone and a beginner telescope to take pictures of the beautiful night sky? Now, you have already addressed this, but if you could add any more details that would be helpful, I'm sure she'd appreciate it. She does mention that she has a 10-year-old and would love an affordable option for him to start doing this. So something that parents can do with their young children. What do you suggest? Is this a viable option?
For young children, I've never done this with kids, so I don't know what the best answer to be. I would say that if I had to take a guess, am I coming through? It says my internet connection is unstable. So how's my video coming through and audio coming through?
It looks great.
Okay, good. So it's probably on my end. Things are breaking up when your audio is not good for me because I'm getting that message periodically here today. But I would say Canon. I'm a Canon person. I have a Canon camera. Nikon probably makes similar cameras. but Canon makes cameras like the T6, the T6i, which are affordable in terms of DSLR cameras, and they'd probably be the best one to start with for younger people. And again, they're still very good cameras, and I best bet to start with. They'll come with a kit lens, maybe an 18 to 55 or 18 to 135. I know they're on sale sometimes for under $500, $300 or $400 sometimes. So I've seen some very good deals on those type cameras. They're a few years old, but still very good. And of course, you can always just start with like a cell phone too, if you have an iPhone or an Android phone of some type as well. If there's a more specific question, I'd be happy to try and answer it, but I think that's why I heard Jamaica ask, because she broke up a little bit. So did that answer the question more or less?
You did, Rob. Thank you so much. Yes, the cell phone and an inexpensive.
Okay, now everyone's frozen on me here.
Yes.
So I'll just try and keep going for a minute. So I do recommend that if you're going to do a cell phone, you want to be able to put on a tripod. So you need some sort of modest tripod. Doesn't have to be a very heavy duty tripod because cell phones are light. So a lightweight tripod is probably okay for a cell phone. But you do want some sort of adapter. Amazon sells brackets that will attach your cell phone to a tripod for $10 or less sometimes. I have like a $7 one from Amazon I've used for a long time. Unfortunately, my colleague has borrowed it right now, so I don't have it in front of me here to show you. Cell phones will have to have a manual or pro mode of some type. This cell phone has a pro mode where I can actually set the focus and set the ISO. ISO is how sensitive the sensor is to light, and set the exposure time. And I can even set white balance too, which I usually leave set on auto and tweak it in post after I take the picture if I need to tweak it. There are some apps that will give useful features for astrophotography for the iPhone. There's a program called Night Sky Capture, which does a great job with iPhones, lets you set all those features manually. So I set my phone to 15, 30-second exposures. The ISO, how sensitive it is to light, you want to set that up nice and high. So my camera goes up to 6400, but the picture gets very noisy, so I usually stop at 3200. Still a bit noisy, but usable. And after I take the picture, I adjust the contrast in levels using just the image editing app on the cell phone. And you can see to the right what I get with my cell phone on kit peak. So I get a very nice picture of the Milky Way, which is reasonably good for a cell phone, I think. So that's one I've just loved that picture right there, because it shows the power of a modern, semi-modern cell phone. Like I said, new ones are even better than that. The Google Pixel phones have a dedicated astrophotography mode. I've never used one. I don't have a Pixel, but I've heard they're even better than this. And this is a pretty good start right here. So you can also take pictures of wide field planets and moons. I'm going to go on to that. I just had the one cell phone picture there. I have taken others as well. I'd hope to do some more this week because the moon is out of the night sky, so I hope to get a couple Milky Way pictures this week. But one of my favorite things to do also is wide field images. Find pretty groupings of planets, the moon, bright stars. Frequently, you get Mercury, Venus, Jupiter, usually within an hour or so before sunrise or after sunset. They're nice and low in the sky, so you can get nice foreground objects in them, like I did the saguaro right here. Exposures are usually ISO 1800 to 1600. Exposures, depending on how long you are after sunset, might be 5 to 15 seconds, depending on your ISO. You should go for a fairly low f-stop. Focal rate, the f-stop is how wide the camera opens the iris to capture light. And each lens has a certain maximum it can open up. And low f-stop means it opens really wide to capture a lot of light. High f-stop means it's a very, very small opening, so you don't capture nearly as much light. And usually take a few shots, test some different exposure times to see what things look like right there. Oops, that's not what I meant to do. I didn't want to do that yet. I'm trying to move the, there we go. Yeah, so this picture right here, you can see that we have the crescent moon with a nice saguaro. We have the planet Mercury up high, and just down in the tip of the clouds here, that nice sky down here is Venus. So this was just earlier this year, May 24th, just a few weeks ago, we had the crescent moon, Mercury and Venus right in the night sky together. The star to the right of Mercury over here on the very right side of the image as well. I forget the name of it. It's one of the stars in the Auriga. It's one of the stars in the Auriga, but I forget the name of it off the top of my head. So, but I know which star it is. So, oops, and why won't, there we go. More wide field planets I did. This one on my left is a very fun shot I did here. I actually was in the February 3rd of 2016. We actually had all 5 planets and the moon visible in the morning pre-dawn sky in Tucson. So this is a 5 a.m. picture here roughly, and I intentionally put Mercury between those palm trees over there just for fun. I had to moved my camera back and forth just to get those lined up with those palm trees. We had Venus, Saturn just below the moon, Mars, and Jupiter. And this, as I said earlier, I have that very wide angle 10mm fisheye lens. You can see that the ground is curved here rather than flat. That's the distortion caused by that fisheye effect right there. And then just earlier this year, we had Venus and the Pleiades together. And on April 2nd, I took that nice little fun shot of Venus and the Pleiades. It was still evening twilight, not that long after sunset, so the sky still is somewhat light, but you can see Venus and the Pleiades. And again, I put this one, I took some trees in the foreground just to give me a little interesting foreground object there as well for fun. So I always look for some little foreground thing to put in there. And why? There we go. So keeping on the wide field thing, if you want to go later in the night and do some nice starscapes, there we'll start needing what we call a fast lens. A fast lens has that nice low f-stop ratio, that f2.8 or less is usually sort of where they start considering lenses pretty fast. And of course, you'll need a good tripod. You'll probably be cranking up the ISO to 2000, 3200, or even higher sometimes. To be honest, my highest ISO, how high I will go, will depend on a couple of things. The level of light in the background, the light pollution, or natural sky glow if the moon is up, as well as the temperature, because there's thermal noise in your camera, and higher temperatures have higher thermal noise. So if I'm outside in the winter on Kitt Peak when it's 30 degrees, I might push that ISO a little bit higher than when I'm outside during the summer in Tucson and it's 90 degrees at 10 o'clock at night. So that's also a thing I'd sort of consider there. Exposures usually go up to about 30 seconds depending on the focal length of your lens. If you start going more than 30 seconds or so, you usually get star trailing. The stars are no longer little round dots. They'll start trailing on you. Just a rule of thumb they use, the maximum exposure time is 500 divided by your focal length of the lens. So if you have a 20mm lens, 500 divided by 20 means you go, what is that, 25 seconds? No, 20 times 24, yeah, 25 seconds roughly. It's 24, 25 seconds, somewhere in there. So 500 divided by your focal length will give you a rough estimate of how far you can do an exposure before you start getting trailing. And afterwards, I adjust the photos in Lightroom. Sometimes the sky comes out a little too bright, and I can make that sky darker in the background to make the Milky Way pop a little bit more. So I don't do a lot of Photoshop. That's the one thing I really want to learn, is how to really do the things in Photoshop. I want to learn more Photoshop. I know some tricks, but I'd really love some Photoshop master to teach me all the tricks of Photoshop. But Lightroom can do quite a bit. Yes, Alyssa?
Yes, hello. I have a question about, so you mentioned changing the...
Alyssa, I think you're muted or you're frozen. I'm not getting any audio from you.
Can you hear me now?
I'm still getting no audio from you.
Okay, let me put the
I don't hear a thing you're saying.
Oh,
Alyssa, this is Jamaica here in the tech room. I can hear
We're having all kinds of technical issues here. I don't hear a word you're saying.
that's okay, Rob. Can you hear me now? You can just continue the presentation.
Am I on? Am I still going?
Yes.
Okay, I'll just keep going then. Okay, at least Jamaica's giving me a thumbs up. Okay, so like I said, it could be on my end because I've gotten a couple messages. My internet connection is unstable, but that's a wonderful Milky Way picture from Kitt Peak right there, just a couple of years ago, late last year, 2019. Guys up there. Here's one on the left, is a Milky Way shot over the 2.1 meter on Kitt Peak from June of 2018. That's actually part of a time lapse. I took hundreds of pictures that night and made a time lapse out of it, which was a lot of fun. This is one of my favorites from that sequence. And on the right is one of my favorite pictures. We have the Milky Way in the background there from 2015 out of Tohono O'odham Community College. Kitt Peak is on the Tohono O'odham Nation, so we are their guests. They let us use Kitt Peak as one of their sacred mountains and have an observatory up there. And we go out there and do events with them. We did a star party at Tohono O'odham Community College, and they came up with the idea of launching water rockets. And I said, well, how are we going to see a water rocket at night? And the students at the college came up with the idea of putting glow sticks on them. So I took this picture of them launching a water rocket with glow sticks attached to it in the star party at night. And I just love this because you actually see the water rocket go up there, and they had different color glow sticks on each side. So you might notice you have the yellow and the sort of greenish glow sticks there. The water rocket was slowly rotating as it went up, and you'd see different color glow sticks facing the camera at different times. You'd actually see that rotation of the water rocket during flight. So I just thought that was a really fun idea that they had, and I had to try taking pictures of it, and I was just very happy that it came out as well as it did. That's a very interesting picture that I took there. And we do that every time at their star parties now. They make water rockets, and I'll take pictures of them at night. So this is one of my favorites, though, because we have the Milky Way in the background. Another fun wide field thing to do is International Space Station passes. So you can actually see the International Space Station naked eye. You don't need a telescope or anything. It can be very bright at times. It can be almost as bright as Venus, which is the brightest planet in the night sky when it's its brightest. Go to a website called heavensabove.com is the one I use, and I look for bright passes. Bright passes have small numbers, so you want like a -2 or a -3 pass. And when it says that's the brightness, those are the really, really bright ones you want to go out and look at. Again, very similar to wide field starscapes. I went out there in the desert, Saguaro National Park. Again, you can see it. This is my fisheye lens. You can see how it's sort of curved ground there, so you get that distorted ground effect to it. Take about a 15 to 30 second exposure, so you can actually see the satellite go across that time right there. So that's how far the satellite moves in 15 or 20 seconds. I can't remember what I did for this particular exposure. It was back in 2012. So it was actually with a previous camera. It's not with my current camera. So there's a previous camera that has long since died, unfortunately. So here's a couple more ISS passes. One on the left is from Kitt Peak from 2015. And this one on my right is the ISS pass at Grinnell College. I was there for a college reunion back in 2018. Their observatory, I don't know why they had they had the light on here so alumni could come in and visit the observatory that night and not trip on the sidewalk. So I had to try and dodge that light. But I took a whole series of pictures, then layered them in a program called Star Stack so you can see the entire path of the satellite. Here's an iridium flare in the upper left. This bright one is a satellite called an iridium satellite, which reflects sunlight back to Earth and lights up very brightly. I had two other faint satellites in here too that I did not know about, but when I took the picture that just happened to show up and photobomb my picture. So this is one picture that actually had 4 satellites in it at one time, which was kind of an interesting thing. One of which I knew about in advance, 3 of which just showed up after the fact. You can also do star trail images. Now this is one of my favorite star trail images. Take a very wide lens. I think this is a 14mm lens I used for this one, if I remember correctly. I forgot to put what that is on beneath this picture. I took hundreds of pictures, usually 15 to 30 second exposures. There's something called an intervalometer. Some cameras have them built in. Some you can buy external ones for fairly inexpensively. You program them and it'll just take a picture every 15 seconds and keep taking pictures all night long until you tell it to stop. So I'm not standing at the camera this whole time. I can literally put a camera out, push the button and walk away and come back later and pick it up. And then I take these pictures and use a program called Star Stacks, or you can do it in Photoshop. Star Stacks is nice and easy, and you can see this telescope is the McMath Pierce Solar Telescope at Kitt Peak. And this is polar aligned. So this telescope points right to the North Star. So this little dot in the middle right up at the tip of it is the North Star. And you see all the stars rotating around the North Star. And this was a nice moonlit night. The moon was behind me because the moon is in the southern sky and this is facing north. So you can sort of see the nice lit up telescope at night there. So if I do it with not a moonlit night, things are much, much darker. So, and here's the left one is more star trails. I did it at CTIO, Cerro Tololo Inter-American Observatory. It's a southern observatory in Chile. The mountain Cerro Tololo we have there. It's kind of a southern version of Kitt Peak, our observatory near Tucson here. That's the 4-meter telescope, the Blanco 4-meter, which is almost a copy of our 4-meter telescope we have at Kitt Peak. So this is and of course, this is the south celestial pole toward the upper right. I sort of have the stars here to the left here. This is also my fisheye lens. You can see it's that curved ground. On the right is a star trails from Kitt Peak. Again, the big scope right in the middle is our 4-meter scope, equivalent to the 4-meter scope there. And there's a moonlit night, so you get the took nice exposures and have the foreground lit up very nicely so you can see the telescopes and the vegetation on the top of Kitt Peak. And that's all moonlight. That's all moonlight. So you can still see the stars, but the foreground is lit up by the moonlight on Kitt Peak. That's another thing that's fun to try is the star trails. Now, one of my real hobbies I love, and I'm sure anyone who knows me knows, I love doing sunset photography. I just have a passion for green flashes and atmospheric optics and the strange things you see at sunset. And one of the great myths of green flashes is you need to be near water. And I'm going to do a spoiler here for you. You don't. I get green flashes here from Tucson all the time. The first green flash I saw with my eyes was actually at Fermilab in Illinois. And that's nowhere near the water. I'm looking west. Lake Michigan's to the east, and I was looking west. There's not a lot of water to the west of Fermilab. So you don't need to be near water, but I will give you the warning that I don't use a solar filter for these, and you don't want to leave your camera pointed at the sun for extremely long periods of time, even near sunset. But near sunset, you can leave your camera pointed at the sun for a few seconds, and it'll be just fine. So, because the sun is not nearly as bright when it's low in the sky as it is when that's high in the sky. But you want to be a little careful. I've never damaged a camera, and I've been doing this since 2009. So it's my first screen flash picture. So in 11 years, I've never damaged a camera. So you got to try to damage it a little bit. It's like, but do it near sunset when the sun's just barely above the horizon, and you'll have good luck. You need at least about a 250 millimeter lens and a tripod to do this. Those exposures, of course, are really short, usually a few thousandths of a second at most. Your ISO is low because you have plenty of light. And sometimes I even crank my f-stop up much higher. So my f-stop is usually in the 14 to 20 range for these to make that hole smaller so there's less light getting to the sensor. So those are all things I do to get these type of images. This is from CTIO in Chile. Wonderful green flash with multiple green flashes captured in one sunset right there at one moment. So here's a couple more green flash pictures. This one on the left is from San Diego, February of 2019. And this is a very interesting one because you had the green flash just as the sun went down. You also had a ship smokestack here. That ship smokestack caused a mirage of sunlight above the smokestack. So this little yellow light above the green flash is refracted sunlight, which I just found so fascinating and just got really lucky to get that exact alignment on that night. I was just so excited to see that picture, and that's one that's just a real gem of a picture I just love. On the right here is from 2016, and green flashes are not always green. Sometimes they can be more yellow, or a really, really clear sky. You can actually get blue or even purple flashes sometimes. This one has more of the bluish green to it, and especially toward the edges of it, you get a little bit more blue in it on my screen. I don't know how it's showing up on yours, but you get a little bit more blue in it. So this is a more bluish green flash than a green flash. And I have occasionally, on rare occasions, gotten violet flashes too, but you have to have very, very clear skies to do that. And I have gotten that a couple times. These are taken with my 600 millimeter lens, so a very, very long focal length lens to get these to magnify the sun a great deal. So there's that. I love those green flashes and that sort of thing. They're just some of my favorite images I get. I also love sunset, these things called crepuscular rays. Again, this is sort of wide field stuff. These rays that come out in the sunset, the sunlight filtering through clouds, causing these long rays. And sometimes on rare occasions, these rays will actually go all the way across the sky, and they actually converge opposite the sun in the sky. So on the right here, this is my full frame fisheye. I promised you I'd show you one fisheye picture, because this picture shows you the rays on the top of the picture, and this one is west where the sun is just set. The rays come from the sun, they spread out, they go all the way across the sky, and they converge opposite the sun, 180 degrees in the sky from the sun. So I need this full frame fisheye lens to see the entire night sky. And of course we have this little dot right here, which you might notice is the moon. So when you look at the whole sky at once, the moon is a very, very small portion of the sky. So that actually is the moon, that little dot there, which is kind of interesting, seeing how small the moon really is against the entire night sky. Another thing I got into a couple of years ago was doing photography of the sun, particularly ISS solar and lunar transits. The International Space Station sometimes crosses right in front of the sun. And you can actually photograph it if you have a proper solar filter. So again, this is with my 600 millimeter lens, so you do need a fairly long lens to get detail on the station. But I've seen people capture it with the lenses as short as 250 to 300 as well, which a lot of cameras come with 250 to 300 millimeter lenses. They call them kit lenses bundled with the cameras. So if you had a solar filter, you can actually do this. You do need a solar filter. They're available fairly cheap on Amazon. Bader solar filters are what I recommend. I like my Bader solar filter, but Rainbow Symphony makes some nice solar filters too. They're 10, 20 bucks, so they're not expensive for a small solar filter for your camera there. Again, this is fairly short exposure because the station moves very fast. It takes about a second to go all the way across the sun here if you get a nice close pass like this one. This station was about 436 kilometers, I think it was on this one. It was less than 440 kilometers. I remember that as one of my closer ones. And you can actually see a fair amount of detail. You can see solar panels and the shape of the station on this. There's two ways of doing it. I usually like recording video. I record 1080p video and then go back and extract the individual frames and layer them to show the motion of the station across the sun. I zoomed in on one of those little pictures to show you what the detail on the left there, to show you a little more detail you can get on this one here on the left. Sort of inset that over the blank part of the sun for you so you can see that. But these are a lot of fun to do. You use the program transitfinder.com. It's a website. There's also an app on your cell phone, which you can use to find out exactly when and where these take place. And I'll give you a warning, these things take place only over a very small fraction of the Earth's surface. Again, I think that this one has a path width about 5 kilometers, so about 3 miles. So unless you're in that 3-mile strip of the Earth, you don't see this pass in front of the sun. It'll be off to the side instead. But fortunately, the station goes by every 90 minutes. So if you look at this, you can usually find things within a half hour to an hour drive of you a couple times a month. So it's rare, but it's not that rare. So you can find these easily enough. And I've photographed quite a few of them. In fact, I'll plan on doing one on Thursday. So, whoops, I have this is actually on the left is a solar transit. What this is? Oh, I remember this now. This is actually a video on the left. Hopefully the video will play properly. This is a video to show you how fast the station goes across the sun. And of course, I'm clicking now and the video doesn't want to play. Okay. I tested it before I started this and it played just fine. And now it doesn't want to play at all. That's peculiar. But on the right, you can actually see I got one in front of the sun, in front of the a moon, excuse me, on the right. So I'm sorry, my video is not wanting to play for me for some reason. I don't know why. I tested it earlier. So that's another technical thing we'll have to figure out for next time. But that's one of my favorites of the lunar transits. Oh, there it goes. There's something happened. Was there a setting, Jamika, you had to fix? Okay, let's see what happens here. So it's very fast, takes about a second to go across. So watch closely as it goes across. Whoops. Come on, you. Why are you? There it goes. And I clipped it so it's only about a 3-second video, so you'll just see it go across very quickly during this video, assuming everything plays properly. It might load, it might load, and I just went full screen. There it goes. So you can see that it's a very, very rapid transit. So you have to be in exactly the right spot at exactly the right time to catch these things. And if you're not there at the exact second, literally, you're going to miss it. But they're a lot of fun to do. And I just love doing those as well. And I just quit my presentation mode, didn't I? Okay, come on. Am I in presentation mode, Jamika, or not?
No, you are not.
I can't hear you. Oh, come on now, Wise. No, okay, I'm trying to find out and I don't see a button to let me go back to presentation mode. So I'm trying to figure out why I can't go back to I'm going to stop sharing screen for just a second and try and get back in presentation mode here. Oh, my controls are, oh, is that? Yes, we have a, I'm trying to figure out why it won't let me get back in that presentation mode. Okay, I'm going to try sharing screen again here. And then I'm going to try getting back in presentation mode. And I'm not in presentation mode yet, and I don't see a button to let me do it. Oh, it's good? It's good now? Okay, good. Okay, so it doesn't look, it looks weird on my screen, so I'm not sure why it doesn't. But anyway, there's the ISS transit again. So I'm going to go back and look at a little zoomed in astrophotography now at night. And for this is why I use the tracking mounts. Those mounts I've talked about earlier, I have a couple different tracking mounts. Exposure depends on the focal length and the accuracy of tracking, but I have done exposures up to 5 minutes on this. So it depends on the exact length of time I do that. But I need a good polar alignment. I use high ISO and low f-stop as my lens will go for this. You can take multiple images and stack them. There's 2 reasons to take multiple images. One is to improve the signal to noise ratio. So I'll take a bunch of 30-second or minute exposures and I can add them up and get a better picture than just one image. The other reason is to increase the dynamic range. There are some objects like the Orion Nebula where there's places that are very bright and places that are very dim. If you take a picture to see the dim stuff, the bright stuff is overexposed. Take a picture to see the bright stuff, The dim stuff is underexposed. If you take pictures of different exposure lengths, so you can see both the bright stuff, and then combine them so you can see the bright stuff and the dim stuff at the same time. So and again, our human eyes have a bigger range that they can see than cameras. So this actually makes it look more like it would to our eye rather than less. On the right is a 2015 image. I did the Andromeda Galaxy, and you can see it's the nice little Andromeda Galaxy with this little guy right here next to it, little satellite galaxy next to it. So that's a very nice image of the Andromeda right there, which I've enjoyed. Doing back in 2015. And where are we here? Why won't my slide advance again? There we go. Here's a couple more zoomed in photos. Here's the Orion Nebula on the left, which I took pictures. I think I combined pictures. The shortest exposure was 5 seconds, and the longest was about 40 seconds to get this image of the Orion Nebula. So the bright spot in the center is not too bright, but you can still see some of the dimmer, fainter clouds around the outside too. So you get sort of the nice range at the same time there. Then on the right is Comet Lovejoy from 2015, a very nice comet. I took from Kitt Peak up there, so I love that comet, the nice long tail. Another one that's sort of a zoomed in photo. I'm going to try and not spend too much more time here because we're getting toward 4:40 or so, and I want to make sure we have time for questions at the end. Lunar eclipses. The big problem with lunar eclipses, you need to wait for one to happen where you live. You can do wide field views. When the moon is low in the sky, you get a nice wide field image of a lunar eclipse. Or if the moon is high in the sky, it's hard to get a good foreground objects, so you do nice zoomed in views like this one, which was my 600mm lens. Techniques are similar to general photography, so you can find your right exposure and ISO just to get a nice exposed image. There's a program called Lunar Eclipse Maestro. If you want to take images of the entire lunar eclipse, we'll actually automate the process and run your camera and take different length exposures and take exposures every couple of minutes so you can actually watch the entire partial eclipse and total eclipse with the lunar photographer with that program. And I've used that for one lunar eclipse so far, and it works pretty well. So I think that's a good program to try. That's for Mac Macintosh computers, Apple computers. There's a similar program for Windows, but the name of it escapes me right now. But I know there's a similar program for Windows computers as well. More lunar eclipse. The one on my left, this is my sense of humor. I was in Las Vegas for a lunar eclipse. I went outside at 4 in the morning when the totality was supposed to happen, and I was staying at the Luxor, so I took a picture of the eclipse moon over the Luxor Hotel in Las Vegas, which I just strictly for fun. I know I'm the only person that got that picture of that lunar eclipse because I was the only person outside taking pictures on the strip at 4 a.m. in Las Vegas of the lunar eclipse. One on the right is from Kitt Peak on January 31st, 2018. Again, this is sort of a wider field one, so you can see the 0.9 meter dome on Kitt Peak with the eclipse moon up to the right of it. So again, just had to find that right lens to get that frame just right. I think that was a 35mm lens if I remember correctly, so it wasn't a zoom, so I just found a lens that just framed that just about as well as it could be framed. Solar eclipses. I just have to show off our solar eclipses. We had a very big one last year in Chile, but they're kind of rare. You usually need to travel somewhere for totality. You do need a solar filter for partial phases, and totality is short. It's about 2 minutes long, 2 to 7 minutes, longest about 7 minutes. I've seen 3 solar eclipses, all of them have been about 2 minutes long, 2 minutes and change. So I've not had a lot of time to do stuff during totality, to say the least. But the very challenging thing about solar eclipses is it has a very wide dynamic range. The corona is very big, but the outer part of it's very faint. The inner part is very bright. If you take a short exposure to see the bright inner part, you don't see the faint outer stuff. Take a long exposure to see the faint outer stuff, the inner stuff is overexposed. So you need to take a lot of pictures of different exposure times and layer them in Photoshop to see the entire range of brightnesses. And again, there's a program called Solar Eclipse Maestro, which automates this process. I've used it twice on total solar eclipses, and it's been a lifesaver because I let the camera go automatically and I can watch the solar eclipse, so I get the best of both worlds. This is an annular eclipse when the moon is farther from Earth, so it doesn't quite totally cover the sun, and you get just a ring of the sun still visible. This is from the Grand Canyon in 2012 in Arizona when I went up there for the Grand Canyon to capture this one. Great trip up there, and a lot of people up there for that solar eclipse. That's a national park, very popular place to watch it. You can see I wasn't quite on the center line because the moon is not quite centered on the sun. I was a few miles from the center line. If I wanted to get on the center line, I would have had to hike down in the bottom of the Grand Canyon somewhere, and I didn't want to do that. So I stayed at the rim and just let it be off center a little bit. On the left is a high dynamic range. Like I said, I took a bunch of photos of different exposure times and layered them. So you can see the faint outer corona as well as the inner corona as well in the same image. And even Earth shine, you can actually see some pattern on the moon. So during the solar eclipse, light bounces off Earth, hits the moon, comes back to Earth, and we actually see some detail on the surface of the moon with a long exposure during a solar eclipse. Again, if I took that to get Earth shine, this whole corona would be blown out. So I have to combine different pictures to get this one. On the right is last year in Chile, our Cerro Tololo I mentioned earlier, our southern observatory. A total solar eclipse passed right over here. And I used Solar Eclipse Maestro to power my camera to take these pictures and then layer them in Photoshop to create a composite showing the entire progress of the eclipse. And I'd like to thank Pete Marenfeld, our graphics designer at this time, who during totality took my solar filter off this camera, then put it back on afterwards and assisted with that picture. Because I had to have the solar filter on during the partial phases, then have it taken off for totality. And this is my last one, I believe. But one thing I've also gotten in the last few years, and this is my record holder so far, is finding the very, very young crescent moon. The crescent moon, when we say new moon occurs on a certain day, it really occurs at a certain second of that day, a certain time of that day. And if you have that crescent moon occur early in the morning, you can actually find that new moon the same day. And this moon is 13 hours and 46 minutes after new moon. I did not see it naked eye. I found it with binoculars first and then took the picture. So because once I knew where it was, I got my camera out and then took the picture. And 13 hours and 46 minutes is a very, very young moon. So not a lot of people see them younger than that. And it's just a hobby of mine. Now when I see it, I get a moon 14, 15, 16 hours old, I go out and try and find it. The world record for seeing it with your naked eye, I think, is a little over 15 hours and a few minutes. The world record for seeing it with binoculars or a small telescope is 11 hours and 40 minutes. So it's not quite a world record, but it's not bad. It's like that's definitely in the point where not too many people are going to see a moon that young. And so that's another thrill that I find. I just love hunting those new moons. So if you'd like to see more of my photos, I have the best place is probably my Flickr account. My online handle is Half Astro, short for Half Astrophysicist, because I do astronomy and science education. So therefore, I'm a half astrophysicist, as it goes. So it's a bad joke. I know it's a bad joke. That tells you my sense of humor as well. So anyway, I'm on Half Astro on Flickr, Instagram, and Twitter. I post more on Flickr than the other sites. So if you want to see lots of photos, Flickr is your best spot. So at that point, I will call it, and I will take any questions that might be had. So Jamika and Alyssa, are there any questions that are coming back? I just stopped sharing my video here. At 150.
Hi, Rob.
Now you said at 150 you're going to mute me, so I'm right here. So I'm at 448, so we're at 148, so we're at perfect timing, right?
All right.
And Jamika's frozen on me here, so hopefully we'll unfreeze in a second here. I cannot hear Jamika.
Okay.
In case people are wondering.
All right. Well, thank you.
Now I'm hearing something.
We appreciate that. Again, those of you in our YouTube audience, we'd like to thank you for your patience and understanding. Please keep those questions coming in the YouTube chat. I will make sure that Rob gets them, and I will post those answers in the comments after the live stream. Alyssa, over to you.
Hey, Jamika. Hey, Rob. Rob, if you can hear me. I'm going to put some of the questions in the chat, so maybe you can see those, Rob, and answer them here. Let's give Rob a second to try that out.
I can hear you right now. I can hear you right now, Alyssa.
Okay, so there's one question in the chat right now. So if you can take a look at that one.
Yes, 500, the focal length is in millimeters. That is exactly correct. That's how most lenses measure their focal length. So that's exactly correct.
Okay, the next question, in case you can hear me, I'll also list it in the chat, is are taking sunrise and sunset pictures considered astrophotography since the sun is a star?
I consider them astrophotography, obviously. So yes, I consider them, and we have the National Solar Observatory as well. So I'd say that's definitely, we call it solar astronomy. So I consider it as astrophotography as well. Yes. So I consider it as astrophotography as well. Yes. And it's just really cool.
Okay.
There more questions?
That takes care of all of our questions for now. If anyone has any further questions, feel free to put them in the chat and we will answer them in a post later. But thank you so much for joining us today. Thank you, Rob. Thank you, Jamika. And we hope to see you all again next week, Wednesday, at the same time and same place. Mahalo for joining us, and ahui ho.